Welcome to everyone in educational video lecture by Akbar Inamdar. Today we are going to learn about non-destructive testing, NDT. Non-destructive testing, classification and introduction. Destructive testing. In destructive testing, sample under test is destroyed. So such type of method cannot be used for. So in this method, sample is destroyed. So such sample cannot be used for further purpose, and such type of testing means destruction testing can be used to know the mechanical property like hardness, compressibility, tensile strength, yield, because as a sample is destroyed, so this type of testing cannot be used to entire batch fabrication. One or two sample take out and do this testing to know these properties. Another testing is non-destructive testing. In this testing, sample does not destroy it. So under this test means in non-destructive testing, neither physical nor chemical property of material change. So sample can be used for further purpose. An entire lot can be checked for quality testing as well as inspection, evaluating the material, components, and assemblies for the discontinuities and differences in characteristic without destroying the serviceability of part or a system. Classification of NDT tests. Acoustic emission testing, ultrasonic testing, which is based on pulse echo method or resounding technique, radiographic testing, and many more, like ultrasonic inspection method, liquid penetration, dye penetration method, and magnetic particle method. ED current method, one of them we are going to see is acoustic emission testing. In this method, principle is used that a localized external forces like mechanical load, rapid change in temperature or pressure when applied to the material which is under test. So it produces the stress waves, and these generated stress waves can be sensed by sensor which is attached to the surface. So in this method, as shown in diagram, this is a source to produce mechanical external forces, likewise mechanical load, rapid change in temperature or pressure, which can be applied to the material, and because of these, stress waves are generated within the material, and because of this, whatever may be the stress wave generated sensed by the sensor, and we can see it on display. So when the external forces applied, material displacement or plastic deformation is produced inside the material. So this results in generation of trace waves inside the material in the form of short light and high frequency elastic waves. So these waves are detected by the sensor and which is attached to the material. The stress waves shows discontinuities in the material where flaws or irregularities inside the material. When multiple sensors are used, then resulting data can be analyzed by the CRO, evaluating the discontinuities in the part. Application of acoustic emission testing is to inspect quality check, monitor the pipeline, pressure vessel, storage tank, aircraft, bridges, and many more. Variety of components, composite and ceramic components. It is also used in process control application such as monitoring the welding processes. Next is radiographic test. In the radiographic test, it is based on a very simple principle that in radiography, absorption of radiation, likewise X-ray, gamma ray, neutron, electron, such type of radiation always absorbed by the material and scattered from the defects. When you know the difference between the intensities of transmitted radiation from the parts free of defect and having the defects, when you get this intensity difference, then we get the position of defects, position of the defect. In this method, as shown in diagram, this is a radiation source, then sample is placed here which contain flaws and some defects. So transmitted radiation can be captured in photographic plate. So it is a photographic plate, and photographic plate is supported by radiation absorbing material stacks. So in this experimental setup consists of radiation source, sample which is to be investigated, photographic film, and radiation absorbing material stack. So material which is to be under investigation is placed in the path of radiation. So it's a radiation. Material is placed in the path of radiation and photographic film placed just behind it and supported by the radiation absorbing material stack. So when this diverging beam is fall or incident on the material which is to be under test, depend upon thickness and property of the material, some amount of radiation is absorbed by the material and transmitted is known by the formula I is equal to I naught e raised to minus mu x, where I is transmitted intensity by material, I naught is incident intensity on sample, T x is the thickness, and mu is the attenuation coefficient. The absorption in part having the defect and free from the defect is always different. So knowing this difference in the radiation density or radiation intensity, which will be seen on film when film is developed. So there is an area of different image density which corresponding to the defects in the material. The application of radiography is X-ray, neutron, or gamma ray radiography is used to detect defects such as cracks, flaws, cavities present in the material or metal casting. Next is thickness measurement or gauge measurement. By using ultrasonic pulse ecosystem or echo sounding technique. The simple principle used here is this method is based on principle echo sounding technique or simply resounding. In this method, ultrasonic waves generated by the transducer. It is a transducer, this sample under test, and it's a support. So when ultrasonic waves are generated and these are directed toward the object which is under test, and when reflected, these reflections are received then it is again sensed by the transducer. And by knowing the velocity of ultrasonic wave in the medium means sample and time to complete one round trip, time to complete one round trip, and it's a velocity. We easily can calculate the thickness of sample or the distance between object from the source. This method, piezoelectric transducer is attached to the material or sample under test either by direct or using incompressible medium like oil and else. Likewise, when same technique, likewise in ultrasonic testing to know the photostatus, incompressible liquids may be used. In this, transducer convert electrical signal into the ultrasonic waves, which propagated into the sample and travel through the sample and reflected back from the opposite surface of the sample as it finds a dissimilar boundary. Dissimilar boundary means medium change. Everyone must know that when medium change, any kind of wave must be reflected. All kind of wave must be reflected, medium change. So travel through the sample and reflect back from opposite surface of the sample because sample is over there. So dissimilar boundary. So these waves are reflected back and these waves are sensed by the transducer and convert these reflected waves again into the electric pulses. By knowing again velocity of waves, velocities of wave in the medium means sample and time to take or complete a round trip by ultrasonic waves, the thickness of sample or distance between the object can be very easily calculated. Application. This technique is used to determine gauge or thickness of metal blocks, sheets, and etc. Next, flaw detection. The flaw detection is the same principle as used in the previous, that is echo sounding technique or resounding. In this also, ultrasonic waves are generated by transducer and directed towards the object and reflection is received. And knowing the velocity of ultrasonic waves in the medium and time to complete one round trip by the waves, thickness of object or distance between object can be calculated by again the same formula T is equal to Vt by 2. In this method, so it is a transducer which generate the ultrasonic waves and send into the sample under test. So in this method, transducer is attached to the sample by using incompressible liquid. This is a liquid layer. And this transducer is excited by high frequency generated and it generates the ultrasonic waves and send into the sample which contains the flaws and result can be monitored on the CRO unit by amplifying the signal. Here, the ultrasonic waves are sent into the sample and when these waves are transmitted from the top surface of the material at regular interval of time to inspect the specimen or sample. These pulses will be reflected back by reflecting the crack, flaws, or any impurities present in the sample. Otherwise, the waves are reflected from the bottom surface of the surface as the boundary change. The peak A will be appear on the screen of CRO for the pulse transmitted from the surface of specimen. So this is the peak A will be because of pulse transmitted from the surface of this sample, and peak B will be present before C if defect is present, and the peak C will be indicate the waves which are reflected from the bottom surface. So C will be comes before as waves comes at C point because it travel less distance. It seems the dissimilar boundary by flaws or defect which present impurities in the material. So B will be coming before C. And by knowing the time delay between peak A and B, standard reference is A, the time difference between time delay between peak A and B, if we know that this is the time, and velocity of sound in the median, means sample. If we know this, then we can find the position of flaws or detect position of cracks or impurities present in the formula by using this formula. May hope you understand the non-destructive testings and how the simple principles used to define the applications to measure the crack, flaws, radiography, and n number of methods to find out or for quality check. Thank you for everyone. Thanks again.